Hi and welcome back to my series on math shortcuts. In this video, I'm going to discuss and demonstrate a method that was proposed by Professor Pu Shen Lo of Carnegie Mellon University in the last quarter of 2019. And this is a method that is particularly useful in solving quadratic equations, and is a good alternative of the quadratic formula. So here I have a quadratic equation: x squared minus 16x plus 48 is equal to 0. Now my task is to find the roots or find the zeros of this equation. According to Professor Pu Shen Lo, the steps are: first, we take the opposite of the coefficient of the middle term. In this case, the middle term is minus 16x, and we take the opposite of minus 16, so we get positive 16, and we get the midpoint, or we get the half of 16, so we divide this by 2 and we get 8. And our step 2 is to get a distance, so we denote that by letter W. This distance is equal to the square of 8, our result in step 1. So we square 8, we get 64, minus the value of our constant in this equation. We have 48, so that's minus 48. Actually, this one is not yet u, but this is u squared. So we have u squared is equal to, if we simplify 64 minus 48, we get 16. And to solve for u is equal to the square root of 16, which is equal to plus minus, or plus positive negative 4. Yeah. Now our u is plus or minus 4, but we will take the positive. Although the negative can still be used and we still arrive to the same result, but we will take the positive for convenience. Now with this value of u, we can now find the roots. No? So root 1 is simply equal to 8 plus 4, our u, and if we simplify 8 plus 4, we get 12. So this is our root number 1. Root 2 is equal to 8 minus 4, which is equal to 4. So here we have the two roots, which are 12 and 4. What we did, again, on step 1 we just get the midpoint. Step 2, we square the midpoint minus the constant of the equation, so we get 16, and we get extract the square root, so we get plus and minus 4. And after that, we can now find the roots. So instead of factoring and using the trial and error or the guess and check method, this method is a bit handy, and the steps are very easy to follow. Let's take a second example. Here I have a quadratic equation: x squared plus 38x plus 72 is equal to 0. Again, we need to find the roots or the zeros of this equation. So step 1, according to Pu Shen Lo's method, we get the half, but first we need to negate or get the opposite of positive 38, so we get negative 38, and get the half or the midpoint. Negative 38 divided by 2 is negative 19. Next step is we square negative 19 and we subtract it by 72. So and we denote that by u squared. U squared is equal to the square of negative 19. So here we have negative 19 squared minus 72, and simplifying that, we have 361 the square of negative 19 is 361 minus 72, and this is also equal to 289, and finding u is equal to the square root of 289, which is equal to plus or minus 17. Now we have the value of u, which is plus or minus 17, but we will take again the positive sign. We can now find our third and last step is to now find the roots. So root 1 is equal to negative 19. This is the result of our step 1, plus our u, which is 17, and root 1 is equal to negative 2, because negative 19 plus 17 is negative 2. Root 2, or the second root, is equal to negative 19. This time we will have the minus sign, 17, and this is equal to negative 36. So here we have our two roots, negative 2 and negative 36, and if we want to check adding the two roots, negative 2, negative 36, we get negative 38, which is actually the middle term, and multiplying negative 2 and negative 36, that's equal to positive 72. For our third and last example, I have here 2x squared minus 32x plus 126 is equal to 0. Now here, this is different from the previous two examples. Here I have a coefficient on the x squared. So according to the method, we should be able to produce an equation that has a coefficient of 1 on x squared. So what I will do here is I will divide all of this by 2, or multiply this by 1/2. Okay, so by dividing by 2, 2x squared divided by 2 is x squared, and 32 divided by 2 is 16x, and 126 divided by 2 is plus 63, and still equal to 0. And then with this form, I can proceed to the steps of the method. So I will get the opposite of the coefficient of the middle term. It's minus 16 here, so I will get 16. So that's 16 over 2 is equal to 8. And step 2 is to have a u squared for a distance, which is equal to the square of 8. So this is 8 squared minus the constant, which is 63. And simplifying, 8 squared is 64 minus 63, and this is equal to 1. So u squared is equal to 1, hence u is equal to the square root of 1, which is equal to plus or minus 1. Now for our last step here, since we already have found the u, we can plug this and find the root. So root 1 is equal to 8, the result in step 1, plus our u, which is 1, and 8 plus 1 is equal to 9. So our first root is 9. Root 2 is equal to 8 minus minus 1, the u, and that is equal to 7. And if we check 9 and 7, this gives us 63, and 9 times 7, this gives us 16. Therefore, these two roots are correct, 9 and 7. Now, why does this method work? So here's a short proof. Now, if we do factoring, we usually have two factors for this, and we have the form x minus root 1 times x minus root 2, and all equal to 0. And if we do the FOIL, or if we multiply these two binomials, x minus root 1 times x minus root 2, we will get x squared minus root 1x minus root 2x plus root 1 root 2, or the product of the two roots. And if we further simplify, we get x squared minus the quantity of the sum of the two roots, so that's r1 plus r2 x plus the product of root 1 and root 2. And if you notice here, this x1 or root 1 plus root 2, or the sum, is actually equal to the coefficient of the middle term x. In this case, root 1 plus root 2 is equal to minus the middle term here, the minus 32 on x. And conversely, the product, which is r1 r2, corresponds to the constant, which is 126. Although we need to factor the two just to have an x squared with a coefficient of 1. But this is basically the foundation of the method. So what I did is to get a half of the sum of the two roots to get the midpoint. That's a step 1. And step 2 is to multiply the roots, and equate them. So if I will show that, so step 1 was to get a midpoint of these two. So in that case, we had 16, we had minus 16, now we get positive actually, so sorry, and we divide it by 2, so we get a midpoint of 8. And after this, we multiply, we add and subtract a certain distance, that is 8 plus u, and the other one is 8 minus u, and this is all equated to 0. Now notice the 8 plus u and 8 minus u, these are the roots that we found on the last step, 8 plus the u and 8 minus u. So this 8 plus u is our root 1, the first root, and 8 minus u is our root 2. And if we multiply root 1 and root 2, this is simply equal to the constant. Earlier we had 63 because we divide all by 2, so we put here, we can equate this to 63. And multiplying 8 plus u, this is a special product, the product of the sum and difference of two binomials. We get 64 minus u squared is equal to 63. And solving for u squared using properties of equality, we get 64 minus 63 is equal to u squared, and u squared is equal to 1, or u is equal to plus and minus 1 using the by extracting the square root. With a u of plus or minus 1, although we will just be taking the plus 1, we can get the roots. So we have root 1 there, 8 plus the u 1 will give us 9, and root 2 is equal to 8 minus the 1, 8 minus 1 is 7. So these are the two roots, and this is how we the proof of this method by Professor Pushenlo of the Carnegie Mellon University. So with this, I hope you learned something from this video. This is actually an easier way, a quick way to find the roots or the zeros of a quadratic equation using the method by Professor Pushenlo. Thank you for watching, and until then, see you and God bless us.